Hi and welcome to today's session on theoretical probability of multiple independent events. Now, when we are dealing with multiple events and we have to calculate the probability for these, we are dealing with terms or and. So probability of this or this happening, the probability of this and this happening. So we can use fractions for both of these methods quite easily. So the or rule, this means that we are going to be adding together our fractions. So the probability of this or this happening, we are going to add together our fractions. So in context, probability of A or B, so two events. So probability of A plus the probability of B if the events are mutually exclusive. Now, by mutually exclusive, what we mean is that the event is not happening at the exact same time, which might affect each other. So, if a event is not, so multiple events are not mutually exclusive, then we must subtract where these are actually overlapping each other. This we can actually take a look at when we look at Venn diagrams with working out the probability of events. And we've got the AND rule, which whenever we are dealing with the AND, so the probability of this and this taking place, we are going to multiply together our fractions. So probability of A and B, probability of A multiplied by the probability of B. If the two events are independent, again, they've got no impact on each other. So the one outcome is not reliant on the outcome of the other one. So let's put these into examples. So the probability of picking out an ace of hearts or a five of clubs from a standard deck of playing cards. There are 52 cards in the playing deck, and there is only one ace of hearts and only one five of clubs. So the probability of picking out the ace of hearts is 1 out of the 52, and the probability of picking out the five of clubs is also 1 over 52. And like we said, when we're dealing with OR, we are going to add together our probabilities. So 1 over 52, add 1 over 52, that gives me 2 over 52, or we could simplify that as 1 over 26. And an example of using the AND instead of the OR. So probability of rolling a 4 and rolling a 5 with two fair dice. So there's 6 numbers on each dice and only 1 4 and 1 5 on both dice. So the probability of rolling a 4 with dice is 1 over 6. The probability of rolling a 5 on dice is also 1 over 6. So the probability of rolling a 4 and a 5 is 1 over 6 times 1 over 6, which gives me 1 over 36. Again, just cross multiplying. 1 times 1 gives me 1, 6 times 6 gives me 36. Thank you very much for watching. If you like what you see, please subscribe.